Yo, Heinsius, you there? Dude, seriously, you wait 2 years for this, and now you're not here? Yeah, oh. All right, well, I think you have. Me. Hi. I am Steven. Well, Steven's avatar. And, yeah. Welcome to 7 Ways to Fail as a Wireless Expert. The only problem is, I am far from an expert. The good news is since I am an AI, I can reach out to a buddy of mine. Her name is GPT-3. Maybe you've heard of her. Let me check in with her. Hey GPT-3, hope you're doing great. So, I've got a situation here, got a full room with 400 people, ready to watch a session called 7 Ways to Fail as a Wireless Expert. Unfortunately, the so-called expert is not here yet. And I, his avatar, now have to do the session. Can you help me out with 7 fails on Wi-Fi?
Sure. Here are 7 potential ways to fail as a wireless expert. 1. Failing to properly plan and design a wireless network before deployment. 2. Neglecting to properly secure the wireless network, leaving it vulnerable to hacking and intrusion. 3. Failing to properly configure and maintain wireless access points and other network devices. 4. Failing to stay current with updates and patches for wireless network equipment and software. 5. Neglecting to troubleshoot and resolve issues with the wireless network in a timely manner. 6. Failing to properly monitor and analyze network usage and performance. 7. Failing to understand and adhere to industry standards and regulations related to wireless networking. Please note that it is advisable to never present information without verifying it, especially on such important matters, as it could lead to dangerous situations. So there you have it, 7 ways to fail. Wasn't that difficult?
Wow! My goodness! 2 years! I've been camping here for 2 years. I've been waiting for you guys. I'm happy to see you here in Amsterdam. How are you doing? I'm super happy to have you here in my hometown in Amsterdam, and we're going to talk about 7 ways to fail on Wi-Fi 6E. On the agenda, a quick introduction. We're going to talk about, I have a screen here. That's happy. That's good. So how it all started, we're going to do a little bit of the evolution of Wi-Fi. We're going to set the baseline because it's always important to understand where we're coming from. Then we're going to look into 7 fails, and we're going to come to a conclusion. So who am I? My name is Steven Heinsius. I'm born in Amsterdam. I have been an end user. I've been running Cisco networks. Then I was a partner. I was a field engineer doing Call Manage and Call Manage Express installations. I've been a distributor. I am now 12 years with Cisco. My starting date is the 1st of October 2010, which gives me 011010. That's cool, right? Cool. And I'm a CCSI, so authorized instructor. Unfortunately, I'll be honest with you, those certifications expired, which hurts, but hey, I still like to do teaching and training. I love that. In my spare time, I'm a dad, I'm a runner, I'm a cook, and that is exactly why I run. I love mountain biking, scuba diving, snowboarding. I'm a singer in a ska reggae band. I'm a Wi-Fi enthusiast. With my good friend Jason and Sofia Strunskaya, we have a YouTube channel called The Basement Series, and if you scan the QR code, you will find our videos, and I would love if you would like and subscribe our videos. We also have come to all the best practices on the Wi-Fi and summarize that into a handout. You can reach out to me on my Twitter handle, and I will send it to you and for free. So, as Simon Sinek says, you always need to start with why. Why did we create this session? Because I know that I would say almost everyone in the room has more knowledge on Wi-Fi than me. So why did you create this session? Well, I wanted to give you, first of all, a set of best practices on Wi-Fi. And I wanted to do that in a light and entertaining way, but also in a way that you would memorize it. But the most important thing that I wanted to create is a set of tools for you to explain to non-Wi-Fi people, like your boss, your manager, your CFO, why something is not working, okay? That is what I'm going to give you. So that set of best practices, it started for the first time in 2016, Cisco Live in Berlin. And I submitted my session for the first time called 7 Ways to Fail as a Wireless Expert. And the Cisco Live organization said, are you sure? Are you sure that you are going to submit a session that is going to teach people how to fail? No one will sign up. You're all here. So I wanted to give that explanation to non-Wi-Fi people in a way that everyone understands. And that has grown into where we are now in the 7 Ways to Fail. I hope when you understand what is wrong with it, you will not make that error again. I hope to make it light and educational, interactive, and a little bit of fun. So for me, as a teacher, as a CCSI, one of the lines that I always said, I don't care how you remember it, as long as you remember it. So I wanted to make things memorable so you can replicate it much easier. So it started with 7 ways. We created then 7 new ways to fail. Then we created the 6 on Wi-Fi 6. And with that, we are now on 20 fails. In the meantime, we also had a sub-division because something big happened about 2 years ago. And all of a sudden, everyone had to work from home. And we also realized that a lot of people don't have the best Wi-Fi experience in their home. So we created a version called the Work From Home Edition. That is all about how to optimize your Wi-Fi network in home. You can find it on our YouTube channel. So to set the baseline, how did Wi-Fi begin? What are the standards and characteristics? And what are some challenges that we see in Wi-Fi? So to get there, I'm going to do a little bit of the evolution of Wi-Fi. I started working in 1997. Which is also the year that 802.11 became a standard. How many offices and businesses had a Wi-Fi network in 1997? I'll tell you, it's a handful. At the beginning of Wi-Fi in 1999, when A and B became the standards, it was a nice to have. It was best effort. The vast majority of companies didn't have Wi-Fi. 2010 is really the moment when Apple introduced the iPhone and when Apple introduced the iPad is when we saw the big spike coming on the Wi-Fi network. And where we are now today is that we're going back into the office. You've heard a lot about hybrid work and work experiences. And that means that the networks where we are on today need to support that multimedia and all those people joining video calls independent from where they are in the building. So that has a lot bigger impact on the network. At the same time, those access points are now part of the sustainability goals of our customers. So to see the evolution of Wi-Fi in a network, picture yourself a customer site with 100 employees, okay? So you take a customer site with 100 employees in mind. You have it? Awesome. How many clients were on that network in the timeline? So 100 employee network, okay? In 99, if there would have been Wi-Fi, it would be 1, 2 max. But the vast majority of customers did not have Wi-Fi at all. 2005, you would see that we were still using those PCMCIA cards, and we saw the first native chipsets coming with onboard Wi-Fi, but almost everyone was still plugged in with a cable. 2007, that is when 802.11n was introduced, and as part of 802.11n, 802.11i was there, which gave us a lot more security features, and from that moment on, more companies started to realize this Wi-Fi thing could be actually something good. Also, the reach became better, and we had a higher data rate. and the onboard chipsets from the Intel Centrino chipsets were actually providing good, solid, secure Wi-Fi. Like I said, 2010, the iPad introduced. That is really when the number of Wi-Fi devices on the network ramped. And we see that beyond that, the number of devices that are on a network is drastically increasing. I'm breaking down my fire here. So, evolution of the Wi-Fi, the different standards. Where we are today is we're looking at Wi-Fi 6E. And I hear a lot of confusion coming to us. What is the difference between 802.11, AC, and Wi-Fi 5? It is the same thing, okay? It is for all of us to make it easier in what generation of the Wi-Fi we are. But what is 6E? 6E is the evolution of where we were with the Wi-Fi. I'll jump into more details soon. But the frequency separation is the big thing. So to better understand that, this is the traffic that we've seen on the network on the 2.4 gigahertz and the 5 gigahertz band. As you can see, 2.4 gigahertz being slower, so with that we could actually have more traffic on the 5 gigahertz. But now that we have the 6 gigahertz band that has only dedicated traffic on the 6 gigahertz band, we see that there is a lot more possibility to now have a lot more traffic without it collisioning. So this drastically helps us to transport more traffic on a network. All right, now we're going to go a little bit into some technical stuff. Modulation. It is important to understand modulation when you are trying to explain to your business unit manager or the CEO or the CFO why you need to have more access points. Well, this is an access point. And I've taken here an 802.11 AC access point, 2 spatial streams, 40 megahertz wide channels, a very common access point that you still see in infrastructure. What you see is that close to the access point, you have a higher modulation, like in this case the 256 QAM, and the further you are away, the lower the modulation goes. And I would say Roberta Flack, the singer, she said it way best when she sang.
The closer I get to you, the more you make me see.
So, if you are close to an access point, you have a higher data rate, you have a higher bandwidth. So to better understand that, I'm going to take you to a game called darts. This is a famous Dutch darter. Apparently, I look like a darter. I'm not entirely sure if that is something to be proud of, but this is Michael van Gerwen, Dutch darter. And everyone knows if you want to throw the dart on the right spot of the dartboard, you need to be close to the dartboard to hit the right spot, right? If you're further away, it's harder to hit exactly the spot. So let's say he now hits the spot that he wants to make. All is good. Next transmission. But if he misses, If he misses, they actually make the dartboard bigger. The result, actually, if you make the dartboard bigger, is that you need to throw more darts, right? So it takes more time for you to transmit a message. So that means you don't want to have your dart thrower too far away from the dartboard, because every miss results in a message that is not acknowledged, and if it doesn't get acknowledged, what happens? You get a retry, exactly. And every time when you get a retry, all the other clients need to be silent. So you don't want to have all those retries. Now let's say he misses again, they're going to make the dartboard even bigger. They change the QAM constellation. But if they do, you need to throw a lot more darts to get the same message across. So conclusion, you want to have your clients as close as possible to the dartboard, to an access point. You guys get it? Awesome. All right. Other things that are happening in the air, so we have shadowing, we have reflection, so signals can be reflected on material. We have refraction, which means that the signal moves in another direction when it goes into another medium. We have distortion, and scattering is really a bad result when it goes in all directions. All of them contribute to a more worse user experience as a client. Other challenges that we see in Wi-Fi, customers complaining, or your employees in your company are complaining about Wi-Fi. The Wi-Fi is slow. In my house, it's much faster than in the office. Ooh. I can't connect to the network. Why? You guys from IT did something wrong. Maybe it's your password? I can't roam, so you can't go from one access point to the next access point. It's not as secure as we want. I am thinking, how can I support those devices that are not given out by the enterprise environment? And I am concerned about that guest network and how to properly secure it. I still come to customer sites where I'm asking for a guest network and then provided with a password. And that is a password that they're not removing at the end of the day. Like, wow, is that still happening? Unfortunately, yes. Other challenges that we see, coverage, and not just the coverage inside the building, but people that are concerned that the coverage is actually bleeding to outside of the building. Interference, where we will see some examples there. Changing environments. When you designed that network and you implemented it, it is not the same 2 years later. Completely new environment, new furniture in there, maybe some plants. It is not the same as it was at the beginning. Internet of Things, IoT devices, devices that were connected to your network and very often are not controlled by a human. So very difficult to install, for instance, a certificate on it. Or they have a mechanism where they're sending a little bit of data every, let's say, 3 seconds. Those are new devices that we didn't have when we designed the network at the beginning. Now we're expecting the 5 nines of availability. We know the 5 nines of availability from the traditional PBXs from 15, 20 years ago. That's when they were requested, right? We expect that now on Wi-Fi as well. Well, that is interesting when Wi-Fi is a really difficult environment to manage and to control. So expecting the 5 nines of availability on something uncontrollable as a wireless medium. Can we do it? The answer is yes. You need to consider it in your network. You need to design, and you need to make sure that you do not have a single point of failure. But you can get to the 5 nines of availability. And what you got to keep in mind is that Wi-Fi is the primary access method into your network. So with that, all our offices going into a wireless office, does that result in we don't need switch ports anymore? The answer is no, because first of all, those access points still need to be wired into a switch, right? And secondly, you see that now that we're going into this hybrid work and where we are seeing that the offices are being retrofitted and being updated to the latest standards, that UPoE having 90 watts per port is actually heart and soul of the design of the new environments. Because with the 90 watts per port, we can move away from AC to all our workspace environments to actually do it by DC, which is a lot more energy efficient. And with that, we now can power up devices through the network, like your monitor, like your Desk Pro, and even we see those moving desks being powered by UPoE. So the primary access method into your network is Wi-Fi, and that's how it's going to stay. But it does not mean that the UTP, the Ethernet cable, is going to go away. Definitely not. That is the heart of the new network. So what is Wi-Fi 6? Well, like I said, the numbering scheme has to do with the fact that we didn't like the alphabet soup. So the Wi-Fi Alliance decided to go Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, which would go to 802.11a as Wi-Fi 2, going back into the numbering. Now, when we say Wi-Fi 6, what does it mean? It means 802.11ax, BSS coloring, OFDMA, multi-user MIMO, 1024 QAM, and the target wake time. Let's jump in. So, AX, Wi-Fi 6, is the art known as Wi-Fi 6. I would say it is an art, yeah, because if you see how many developments and inventions have been done to make Wi-Fi as reliable as it is today, I do think it is an art. It is the latest generation of Wi-Fi. What I really like here is that 2.4 gigahertz is back. And we had to. Okay, so if you would have been in an update like 5-6 years ago, they said, this is the end of 2.4. 2.4, very little space that we have. We had only 3 usable channels, right? Lots of interference. We're moving away from 2.4, and it's going to be 5 gigahertz all the way. 2.4 gigahertz is back. So in the 802.11ax standard, 2.4 is there, and it actually supports a lot of those IoT devices that are not equipped with a dual radio. And we can now facilitate them because what makes 802.11ax so much more efficient, we will jump into that, is also available on the 2.4 gigahertz band. 5 gigahertz is leading and expanded to 6 gigahertz. It is the fastest ramping technology so far, and it is not about more speed, okay? This is a conversation that I've had with several IT managers. I don't need more speed on my network. And I agree. You don't need more speed. I also have people asking me, do I need to have Wi-Fi 6 or 6E in my home? Not really. The speed is not what it's about. It's about the efficiency. It is about that extra road that I shared with you earlier in the graphic with the lane separation, and the possibility to have more traffic at the same time on the roads without the collisions. So it is all about efficiency. BSS coloring is one of the features in 802.11ax. It is not actually a color, okay? It's a numbering bit, and with that, we can drastically increase the number of reuse of channels. So you can have a much higher density of access points without creating co-channel interference. That is what BSS coloring is about. Again, efficiency. Then we have OFDMA. Every time when my kids are asking that, do you know a difficult word? I would say, yes, I do. And that word is, and I'm happy I can read it again, orthogonal frequency division multiple access. Basically, what it means is a possibility to have a lot more multi-user traffic send out in one packet. So it goes into the truck, moves out, and then immediately the next one comes up. So with that, we can have smaller allocation units transmitting at the same time. More users providing data into a data packet and get sent onto the network. It's not the same as multi-user MIMO. Multi-user MIMO means that there will be ability for multiple users to communicate to a radio. It is about this. The radio in an access point being able to communicate to multiple devices at the same time. In the difference with OFDMA, it is multiple packets of data, multiple resource units in each packet. We see the difference? Good. 1024 QAM. What this means is that, in fact, in making our dartboard bigger, we made it smaller. And because we made it smaller, we need to throw only one arrow to get a very big message across. The downside is the environment, the noise level needs to be very good for the dart player to concentrate to hit it on the exact right spot. So the 1024 QAM gives us a lot of benefits, but it also increases the need for a real clean air. Clean air, yeah. Target wake time. Very often I have a target wake time as well. Typically, I don't make it. But the target wake time is a way for IoT devices to be a lot more efficient in the way they communicate with the infrastructure. So it is like going to the butcher or the bakery on Saturday, and instead of trying to get the attention that it's your turn and you want to order something, which is quite energy inefficient, right? So you pick a number, and you're watching the board, and as soon as your number comes up, that's when you step forward and you make your order. That's target wake time. Ideally for IoT devices to reduce their battery transmitting on the network when they don't have to. Then what is the E in Wi-Fi 6E? The E is for evolution, efficiency, experience, extra bandwidth. Basically, it is all the goodness of Wi-Fi 802.11ax on a new bandwidth, providing us 500 megahertz in spectrum on the 6 gigahertz band. All right, clear on the basics? Yeah? All right. Time to look into some fails. So, fail number 1, you missed all the previous episodes. If that is the case, don't worry, we published them for you. We put them all behind a QR code. You can simply scan the QR code. It will get you to the session. So if you want to see the original 7 ways to fail, is the number 1 on the left. In the middle, 7 new ways to fail. On the right side, we have the 6 on Wi-Fi 6, and that also really goes into radio and radio patterns and radio designs and antennas. And then I really like this one. This is the work from home edition. Please use this one every time when you have a colleague or a friend, not a colleague, you have a friend or a family member that says, you work in IT, right? We know this question, yeah? Don't answer it. Like, I'm in sales. You work in IT, right? My computer has this issue, or I can't connect to the Wi-Fi. Send them this video. It's a very simple explanation on 7 things that everyone can improve in their home Wi-Fi. And for this one, we made a handout as well. All right. So the simple rule for fail number 1, never stop learning, but make sure you have a bit of fun. Okay? I think, like I said earlier, it is really important to be able, I don't care how you remember it, as long as you remember it. Fail number 2, give me wider channels. We can go wider. By the way, I heard today that we're going to go to the 320 megahertz wide channels. Wow. All right. So, where we are, 2.4 gigahertz and 5 gigahertz band today. In the 2.4 gigahertz, we all know there's 802.11 B, G, and N on 2.4. And we have, here in Europe, channel 1 till 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 12 and 30. And the only ones that we can use is 1, 6, and 11. Giving us 3 times 20 megahertz wide channels, which is absolutely nothing. But still, it is quite a lot of science behind it to make that happen. And now that we really standardized on 5 gigahertz, we will see later on how much traffic is going on 5 gigahertz. And I think almost all your devices in your pocket and on your desk use the 5 gigahertz band. Because we do that, we now have the possibility to do what we call channel bonding. And I know there was channel bonding as well in 2.4 gigahertz. And when I do a scan on a Wi-Fi network, I still love doing those scans on a Wi-Fi network. If you do that, if you do it at home, you will see that one of your neighbors is still doing channel bonding on 2.4. Don't do that, okay? No channel bonding on 2.4. Because if you do, you get a lot of overlapping channels, you get a lot of noise. But in the 5 gigahertz, it's absolutely fine. Should you do 160 megahertz wide channels on 5? I would not recommend it, unless you have a little farm in the middle of nowhere, then it could be. But if you have neighbors, I would not recommend it. Could you do 80? The answer is sometimes yes, sometimes no, depending on your use case. Personally, on the 5 gigahertz band, I would recommend 40 megahertz wide channels. So the unlicensed spectrum used by Wi-Fi, you see that in 2.4 we have very few bandwidth. In 5 gigahertz we have a lot more bandwidth. And with the 6 gigahertz, especially in the US, we have a lot of new untapped bandwidth. This results in the following. You can have in the 6 gigahertz band a lot of new channels, both on 80 megahertz and even onto 160 megahertz wide channels. So with that, you can actually use those channels in a very wide setup. So I would say my personal recommendation for the 5 gigahertz band, standardize on 40. Okay, don't go to 80. Standardize on 40. However, on the 6 gigahertz band, it's absolutely fine to do 80 megahertz wide channels. And like I said, on 2.4, never move away from single channel. Okay, don't do channel bonding on 2.4. One of the tools that I use a lot, and I would recommend you to use this tool if you want to do a quick scan on the Wi-Fi. This is my favorite tool for it. It's Wi-Fi Explorer. There's a version available in Wi-Fi Explorer Regular and Pro. And this is how it looks like. I really like using this tool because it's very simple, and I just love using this device for a quick scan. This is actually my home network, what you're looking at. On the right side, you see my 5 gigahertz band. And on the left side, there is my network, but there is also some neighboring networks. And here you see a great example of channel bonding going on, using the wrong channel and then still doing channel bonding. As you can see, there's a lot of overlap there. So this tool, and by the way, the blue, what you see in the background, is actually spectrum analysis on the 2.4 gigahertz, which you can also do in the Wi-Fi Explorer tool as a feature. So the inventor from Wi-Fi Explorer, his name is Adrian Granados, and I asked him for a discount voucher for you guys. Here you have it. If you go to his website and download the software and use the code Cisco Live Europe 30, without the dot behind it, by the way, then you get a 30% discount for the tool. So the simple rule on this one, 40 for 5, 80 for 6. But whatever you do, never mix. Okay, so if you're going to go for 80 megahertz, that's absolutely fine, but do it on the 6 gigahertz band, but don't do it on the 5 gigahertz band then as well. 40 for 5, 80 for 6, whatever you do, never mix. After all, size does matter, right? Fail number 3, not aligning the primary and the secondary. Because you basically block a channel, and we've seen what happens when you block a channel, right? What does it mean? In the 6 gigahertz band, we have agreed that the primary channel is the second channel, okay? Is that an industry standard? Is everyone doing that by default? Unfortunately, no. Unfortunately, it is a best practice and a recommendation, and a lot of people and a lot of vendors do it, but not everyone. What is the impact if you do this? Well, let's have a look at the entire spectrum on the 6 gigahertz band. We're going to standardize for this particular situation on 80 megahertz wide channel, and I'm now having a proper configured access point where the primary channel is in channel the second channel. This is the channel where all the management frames go on. This is where the communication between the clients and the infrastructure is happening. That is happening on that particular channel, the primary channel. Now, if another access point would be in there, that has the primary channel on channel 1, they don't communicate to each other. They don't hear each other. Okay, so all the management frame information is not there. They don't, well, it is there, but they don't see it from each other. The result of that is that you get a lot of noise. So don't do that. So the simple rule in this case is do not mess with the defaults. Do not mess with the defaults. Fail number 4, this is my favorite one. Placements of access points. Really? Does it matter? The answer is yes, it does matter. Some examples here. Protecting your Wi-Fi access point. Yeah, I see that this is very well protected. This is a picture taken on a school, okay? And the thought process from the school was we are protecting the access point. And I said, yes, do you have physics here at school? Do you have a physics teacher? Ask him about Faraday's cage. Okay. So should you not do this? Should you not hide or protect your access point? Yes, you can, but you don't do it with metal. There's actually really good cases from plastic or sometimes even wood to protect those access points. Yeah, if you do not have a way to properly install your access point on a ceiling, you can do it with a plastic bag. It is a quite modern view in the office. Channel bonding. Channel bonding. And I've been working with wireless access points for a long time, and this is one of the features that I did not know we have, but wireless stacking. Which is, of course, absolutely wrong, because stacking should be done in the wiring closet, right? I like a bit of grilling, and when I'm making my pulled pork, I, at a certain point, put it in the aluminium foil. Aluminium foil. I hate the word in English. Aluminum foil. Thank you. Thank you. But don't do that with your access point. If you don't have the brackets, then you can use some tape, or you can use tie rips. When you did the site survey, everything was nice and clean and working perfect and fantastic performance. You did your site survey with your Ekahau tool, and it's all green. And then when they go live, some real nice metal pieces of art. Yeah, your Wi-Fi performance is a little bit different in that case. If you want to do outdoor Wi-Fi, you can do that, of course, in the right way, or you could do it in the little bit cheaper way. MacGyver way, maybe. Hiding it in a Ziploc bag. This is not really how to do outdoor Wi-Fi. I think everyone can relate to that. So, recommendations for putting your access point: put them horizontal because of the polarization. Put them below the obstructions and not between the obstructions. I see that very often. We see two metal pipes or two metal, sorry? Beams. Beams, that's the word, thank you. Two metal beams, and then they put the access point between it. Yeah, that is not the right spot. Put them minimum 3 meters away from each other because of the Fresnel zone, and use the correct antenna and only one type of antenna. I still see implementations where they're putting two different antennas on one access point. A minimum of 3 meters away from each other, and don't put them too high. So when you're going beyond the 4 meters of height, you would use a different antenna or a different setup to make that work. Never put it behind the metal cage, and if you want to do outdoor access points, please do use outdoor access points for the outdoor coverage. So the simple rule for this one, like in real estate, it's all about location, location, location. Luckily, now you have the right tools to help you find that right location. The one extra, unfortunately, I wanted to put one in. I forgot about that because I was setting up my tent. Sorry for that. Hype versus reality. It is really important to do a reality check. Because when the 211 AC Wave 2 was announced, it was all about much more bandwidth. We're going to go way beyond 2 gigahertz. We're going to introduce to you 4x4 with 4 spatial streams. We're going to do 256 QAM. We're going to provide you with 160 megahertz wide channels and multi-user MIMO. All right, let's go one by one. When they were introduced, the 4x4 with 4 spatial streams, there were no clients for it. But it was designed for multi-user MIMO. The radio was there to help us do multi-user MIMO, be able to have multiple clients transmit to the same radio at the same time. Unfortunately, there were no clients for it. There was, when AC Wave 2 was introduced, there was one client actually. There was the Samsung Note that could do it. Unfortunately, it had a little feature that no one really liked called explosion, which didn't make it a commercial success. So that took a lot of time to ramp off. The 256 QAM, yes, it was working, but in order for it to work, the client needed to be really close to the access point, like this close. So yes, it was working, and it was working from the client to the access point, and the access point back to the client. And the 160 megahertz wide channels, yes, again, it was working, but it was not enough bandwidth to really make that lift off. And where we are now in the AX standard, everything that you see in here is there, it's working, it's proven, and it has contributed to a much better experience and a much better efficiency, that is the key word, efficiency on the network. All right, I'm going to do a few demos of some sources of interference. And I have been running here. Yes, you can see it. Splendid. All right, so Christmas came early this year, and I got the new Ecke House Sidekick, #2. I love it. And what you can do with this is spectrum analysis. And as you can see, this has been running for quite a while already. We're looking at the 2.4 gigahertz band in this situation. And here is the 5 gigahertz band. You can see that there's a lot of traffic happening on the 5 gigahertz band. And you can also see that the vast majority of the traffic happening here at Cisco Live is on the 5 gigahertz band. And look at how beautiful silent the 6 gigahertz band still is. This number you will see increase in the next few months. You're going to see this ramp up very quickly, because more and more clients that are coming out of out now are going to have those 6 gigahertz radios. And they are all about efficiency, so you will have a lot more possibility. The result of that is that this one will become easier again. So everyone benefits. And even the clients that are on 2.4 benefit from all that efficiency in the way clients communicate into an infrastructure. Now, let me start with yeah, I'm going to start with this one. So, any one of you a parent? Who's a parent? Yeah? Ooh. Productive audience. And who's recently become a parent? Only 3? Okay. Do you guys have a baby monitor? You do. Let me show how the cheaper baby monitors, well, it wasn't cheap at the beginning. Let me show you how a baby monitor is responding on your infrastructure. Whew. This is quite intense, I would say. Right? This is the device that you're putting in your baby's room, your baby bedroom. This is the one that's generating all the red lines that you see here. Now, why is this really bad? Is this bad for health? I don't think so. But it is definitely very bad for your Wi-Fi environment. So if you, in your home environment, have 2.4 gigahertz as the main infrastructure, where very often your access point in home is in the wiring closet, right, where the internet connection comes in, and then the 5 gigahertz doesn't make it through the entire house, but the 2.4 gigahertz does, and your neighbor decided to buy a baby monitor, you will have a lot of issues on your Wi-Fi. So that's the baby monitor. What you see here, this is a good example of RF noise, because it is transmitted wirelessly, but it is not 802.11. It is not Wi-Fi. So all the clients and all the infrastructure do not understand what's going on here. They don't speak the same language. So this is a good example of noise. Let me turn it off, because I actually do see myself right now. There we go. So then you decided to click on one of those advertisements that you've seen on Facebook, on Twitter, to buy one of those cameras that are very easy to install everywhere. They're $30. And you take that camera and you put it wherever you want, and you get visibility, right? You've seen those advertisements, right? And they sound appealing to buy a camera like that. I have one. Here it is. Let me turn it on and see what happens. Wow. Yes, I must admit that it is easy to use. It is also very easy to kill your Wi-Fi. As you can see, it's now even going black, right? This is not what you want to see on your Wi-Fi network. These are those cheap cameras that you see on an infrastructure, on social media, that are really messing up with your infrastructure. So if you want to do a camera, make sure that you get yourself a camera that is actually communicating in Wi-Fi. Because a camera like this, even though they are constantly sending data on the infrastructure, it is done in a way that the rest of the infrastructure understands. They speak the same languages. It's the Wi-Fi language, okay? They are able to hear and listen who and what is transmitting on the network, and able to adjust that into the rest of the traffic. And then you might think, I don't have baby monitors in my office at all, so that is not a problem. And you're right, I get that. So let me show something that you do have in your office. You have these in your office. You might think, what is this? Do I have that? Yes, you do. These are motion detectors. A PIR, a motion detector. And they actually use 5 gigahertz to do the motion detection. Not all of them, but a lot of them do. And if you would power them on, there we go, yes. If you would power them on, what you see here, this is him. Look at how dark it is. So, based on the movement that I make in a building, it actually moves the frequency. It moves that frequency. So if you now have a Wi-Fi network that is listening to channels and listens if there is interference on a certain channel, it will change that channel. Is that what you want? I would say no, because this frequency is moving depending on the movement it detects. So it's moving all the time. You don't want your network to adjust to that all the time, because you will have flipping channels, which is really annoying. Because every time it's flipping, it will reset the connection with the clients. This is one of the many reasons why you need to think about what kind of devices am I attaching to my network, and what kind of devices are able to influence my network and then make a decision on changing the channels. And the last thing that you want to keep in mind is to make sure that you have a clean air environment, so the chipset is able to recognize what it is, and the chipset is able to make the decision, make a well thought through decision on, should I adjust the network based on this device, yes or no? The easier solution is, let's move to 6 gigahertz. And it doesn't stop here. There is a reason why I really like the tools from Ekahau, because it gives me so much more possibility to apply the best practices that we've seen in Wi-Fi and apply them to your business outcomes. And you don't have to be an expert anymore if you have the right tools. Now, to introduce the advanced new features that are coming from Ekahau, I would like to welcome to the stage Anssi, who is the VP of Product at Ekahau. Welcome, Anssi.
Hey, thank you. Great to be here. Thank you, Stephen. You've shown some spectacular examples how to fail with Wi-Fi. And I thought I'd take a different approach. I thought maybe I show you one way how not to fail with Wi-Fi. Is that okay?
That sounds like a good idea, yes.
Okay, thank you. So we at Ekahau, we are experts in RF design and optimization. And based on our expertise, we can really recommend 3 steps to great Wi-Fi. So it's not really that complicated. First of all, a great network starts with great design. So that means that you figure out the right amount of access points in right locations with right configuration. Then the second point is that you validate. After the network is being deployed, you validate it. And basically, that means that you measure the quality of the network, and you make sure that it meets the original requirements and the original design principles. And then the step number 3 is regular health checks. Because even though the network is designed well and it's been properly validated, it will not stay like that forever. The wireless environment changes all the time. And that's why it is important to regularly check the quality of the network and do the necessary actions to fix any issues you have. So let's take a quick look how to do that. So the first step, designing a great 6E network. So the job here is to design, think of what is the right amount of access points in right locations with the right configuration. And for that, I am using Ekahau AI Pro, which is the latest version of our design software. And we have built in a lot of automation features in there to make it easier and faster and more automated to design networks. So I'm going to show you today a feature called AI Auto Planner, which is basically an expert system that takes as an input your requirements and your floor plan. And based on that information, it actually creates you automatically a high-quality design.
Is ChatGPT part of that as well?
Next version.
Next version,
yes.
Okay.
So let's see how that works. So here I have prepared my floor plan, and I have inserted a couple of requirements here. I have here high-performance network, and then I have some lower requirements for the other areas. So it's really easy. I click here, one icon. I select the network access point model. I can change the configuration if I want, but I don't have to. I can go with the defaults. And here's where the magic happens. So basically, the system is running thousands of iterations to figure out what is the right amount of access points. So every time you see a green dot, it decides to add an access point. And every time you see the red, it decides to remove an access point. And as you can see, those dots are moving, so the system is actually looking for optimal position for each of those access points. So here you can see the end result. We did a plan for a 2-store building. The system did 20,500 iterations to find the optimal combination, and it decided to place 104 access points into this plan. And here you see the list of the access points and the configuration on the right-hand side. So it basically it tested all possible combinations to come up with an optimal solution for this particular space. I don't like to brag, but this is really the most advanced Wi-Fi design tool there is out there. And it can be as easy as that. Okay, moving on. Step number 2, validation. So Stephen already mentioned Sidekick 2, and this is the unit I brought with me here today. So it's basically, it sounds like I'm bragging again, but it's the most accurate Wi-Fi measurement device in the market. So what we did last year, we announced a new version of it. It supports 6 gigahertz, but we also added a lot of new features into it. So we basically supercharge every single component. This one has 4 tri-band radios, 9 antennas, really high quality spectrum analyzer, and all the bells and whistles to make it even more powerful and accurate than it was before. Now, the best thing about it is that it's really easy to use. Basically, you can give it to anyone who hasn't even seen it before, and with the survey application, they can do also high-quality surveys. So we say, if you can walk a dog, you can walk a Sidekick, right? So what that actually means, for example, in enterprise environment, is that you can ship the Sidekick to a new location, you can have someone locally do a survey for you, you do a cloud sync, and you can have your expert looking at the data directly from the cloud. That saves you money, time, truck rolls, flight tickets. It's a sustainable way of doing surveys. That's how it works. And since we are a highly scientific organization, we wanted to take it one step further. So if you can walk a Sidekick, if you can walk a dog, you can walk a Sidekick. But can a dog walk a Sidekick? We tried it out. So this fellow here is my dog Touho. It's a very energetic, happy little guy. So what we did is that I built a harness, and I attached the Sidekick to his back, and I tried out if Touho can make a survey. And it turns out he actually loves this game. He thinks it's funny, and he gets properly compensated for his efforts. Lots of bones and meatballs, basically. So here you can see the results. Here's Touho. And that's how you do a survey.
You can rent them by the hour.
Yes. Just make sure you have enough bones and meatballs, and you're well covered. But you know, Touho actually did the high-quality survey. You can see the results here. Survey speed, 24 meters in 3 seconds, so that's about 8 meters per second. If you look at the individual dots here on that picture, each one of those dots is a measurement, right? So it is a high-quality survey. So very scientifically proven, you can't outrun SK2. Even if you run 100 meters in 10 seconds, which probably qualifies you to the Olympic finals, you won't be able to outrun it. Don't worry about it. Okay, so moving on, step number 3. So those regular health checks. Obviously, one way to do regular health check is use Sidekick to measure the quality of your network. But another great practice is you configure your network management system to do 24/7 monitoring. But there's a catch here. It is really easy to fail if you try to provision these dashboards manually. Because basically, the job in hand is that you want to match those physical installation locations into your dashboards that you have in your management system. And you know, sometimes the locations are tricky. You do this by mapping the serial numbers by hand. Serial numbers are always very long, and they contain a lot of characters. So it's actually a lot of work. So in the previous example, we had those 104 access points. In reality, you have to do more than 700 manual steps in order to get all of those 104 access points into your dashboard. And that's actually 700 chances to make a mistake. So it's a lot of work, and it's really error-prone, and it's not really recommended. So a much easier and efficient way of doing this is use Ekahau zero-touch provisioning. So how that works is that you take your sidekick for a walk, you do a survey, you save the results, and then you click and export. So we have an API between Ekahau system and the Cisco Meraki dashboard, and it basically exports your floor plan, your access point location, your serial numbers automatically into the dashboard.
I want to say one thing here. So it says only with Cisco Meraki. So you mean can Aruba do this?
No, Aruba can't do it.
Can Juniper Mist do it?
No, they can't do it.
Ubiquiti?
Yes. No,
Serious?
I'm just kidding. You should have seen your face. No, they can't do it. Huawei can't do it. Extreme can't do it. It's exclusively
Only
for
with
Cisco Meraki. Yeah.
Good.
You
good,
get the
good,
point.
good.
Okay, that's what I wanted to show. 3 steps to great Wi-Fi. So we have a booth here. If you're interested, come and check out the demo. The doc is unfortunately not here. He's busy doing something else. But the other tools, other solutions, we are happy to show. And by the way, we have great prizes, so you can take part into our raffle.
Thank you. Thank you, Ansi.
Thank you.
Okay. So simple rule, now more than ever, you need the smartest chipset. You need the smartest chipset in your access points, in your switches, and in your sidekick. They really make the difference. Fail number 6, you have to listen to the architect. And I'm not talking about you, the architect, because to you we need to listen. So I'm told that access points are ugly. Do you agree? Nah, the new access points are beautiful. But what do we do with things that are ugly? Well, I'll give you a few examples of things that I think are ugly. Cool, but ugly. We can pimp them and tune them, but still ugly. By the way, on Lada, they were the first one that had onboard Wi-Fi, okay? So, with Wi-Fi, put your access points where your clients are. That is a strong recommendation. Why is that? Well, here we have the transmitter and the receiver, okay? So you have an access point transmitting to a client, and typically in an office environment, there is some kind of walls in between. And let's say in a typical office environment, it's a plasterboard wall, which has a 3 dB attenuation. 3 dB actually means that the signal gets reduced by half. Okay? So what you see here is now we have a transmitter and a receiver, and there's a wall in between. We have an access point, and we have a client that is associated to that access point. That is on a short distance. That means that every message that is sent from the access point to the client gets acknowledged. Now, there is a wall in between now, and the result of that is that the signal is half. The access point is transmitting to the client. Does it get an acknowledgement? The answer is no. Because what the client will hear is, is he going to acknowledge that message? The answer is no. So it will result in a retransmit. That is what we don't want, especially if we're going to put our access point above the ceiling, and then on the other side of the wall, we have a client trying to connect. This is what you very often see in hotel rooms, where you are connected to a Wi-Fi network. You do look at your phone and you see 2 or even 3 bars, but your phone is actually talking on a very low level. He's talking like this. Where the access point that they put in the hallway, they cranked up to maximum volume. The result of that is that the access point can very well receive the client, but the client cannot send back to the access point. So because the client then does not get the acknowledgement, it will keep on retrying. And now you are in the next room, and you are trying to get access to the network, but because that other client is doing all the retries all the time, it doesn't get through. Sounds familiar that the Wi-Fi on the network is slow? Yeah? This is why. Keep in mind, a 3 dB gain means double the milliwatts, and 3 dB loss is half the milliwatts, where a 10 dB is times 10, and 10 dB loss is divided by 10. So keep in mind that 70% of the clients on your network are smartphones. They're phones that have a maximum transmission of 25 milliwatts, and typically they're lower. Typically they're lower than this. They can go to a maximum of 25, but they go lower because we want to save battery. So what you need to do is, first of all, make sure that you have short access to an access point, so it doesn't have to do a lot of darts throwing, right? And the second thing that you need to do is make sure that those access points are actually talking on the same volume. So you don't have an access point in a hallway screaming to a client that is talking very soft, because it doesn't work. So here you see what we have here in Europe, the ETSI standard. We can do a maximum of 100 milliwatts, where 100 milliwatts equals 20 decibel to the milliwatts. And what we recommend typically is to have it on maximum 14 decibel to the milliwatts to make sure that you are in line with your client. So this is the one to go for. Now, here we go back to the transmitter and the receiver, because at a certain point, the client needs to talk back. And that is why it is so important that they are in sync. What you see here is that the previous situation, the receiver could, the access point could reach the client, but as soon as it moves around, they can't reach each other. Especially when there is a wall in between, that is really getting difficult. So architects told us that access points are ugly. What about these? They're not ugly? Dear architect, if they are not ugly, they are ugly, right? So why are you not hiding them? Anyone? Then they don't work. Aha! The same with your Wi-Fi. If you hide your access point, they don't work. So some of you have been really smart and invented the peephole AP. Example? I do like the one on the right side, by the way. I really like that one. The one on the left side, can you imagine being in your hotel room and seeing that little thing creeping out of the wall? This is what you should do. If you want to hide your access points, there's actually really good solutions to do that. There are frames for all brands and models of access points to properly install the access point in the ceiling and making sure that they are now part of the aesthetics of the room and the building, but they do function as an access point where you can still see the clients. Also for outdoor, there are really good solutions. I like the Oberon. If you want to hide your access point outside because you don't like this big machine with all the huge antennas, you can actually do that in a very nice way with a solution like this. So my favorite simple rule for this one is, can you read the logo? You're probably good to go. It is all about being able to see that logo, and I hope it's a Cisco one, of course. But if you can see the logo, it means that you have vision on the access point, it's not being blocked, and it is not too high, right? Because if an access point is really high, you don't see the logo. Agree? So simple rule, can you read the logo, you're probably good to go. Fail number 7, I'll wait for the next upgrade. If you look at how the network is transitioning, and if you look at how important it is now to have the right user experience, application experience, employee experience, customer experience, security and network operations experience, now more than ever, you need a reliable network where you have a large amount of clients that are able to communicate with multimedia without buffer, without jitter, without packet loss, at the same time supporting IoT devices that were not devices that are not controlled by a human, accessing the same network, and being able to get data from that infrastructure about what is the temperature in a room, what is the amount of people or devices in a room, how often are these devices here, how long do they stay here, does the temperature level go up, does the air quality stay in the right level. All that kind of information you can now get from your latest and greatest generation of access points, which feeds back into solutions like Cisco Spaces to make hybrid work happen and work in those environments. This is the fastest transition ever, and you should not wait till tomorrow with what you can do today. So in conclusion, Wi-Fi 6 is here, it is real, it's happening, and it benefits us all. Thank you so much. It was really fun to be here. It was really fun to do it. And I hope I could give you what you can help to communicate to non-Wi-Fi people in your organization on explaining why things need to be improved, why it is important to have a stable, solid Wi-Fi network, and getting data out of your network to make business decisions. It was really fun, and I'm honored to have you with me here in Amsterdam. Reach out to get the handout. It's free. Please use it. I always I try to make the world better by giving you a better connection. I'm more than happy to share it with you. So with that, you've learned 7 things to look at when you want to be an expert. You have learned 7 things to look at when you want to hire an expert. And it's really important for you to think that if you think hiring a professional is expensive, wait till you hire an amateur. But if you search well, there's always someone willing to do it cheaper. That's it. Thank you very much.